Hello friend, how are you? I am fine. I think you will be fine. Anyway, today I hope you will be fine. Today, lecture number 4 of crystal field theory CFT. CFT we already studied in the previous lecture octahedral complexes. We applied the CFT crystal field theory to octahedral complexes. So now what is the electron? If there is, what is the electronic arrangement in central metal atom? What is the electronic arrangement in central metal atom in case of when there is strong ligand or weak ligand? What will be happen? How we will be arrange the central metal atom configuration? So if the strong ligand, if there is strong ligand, if there is strong ligand, if there is a strong ligand, a strong field, if there is strong ligand, then low spin complexes will be formed. Low spin complexes will be formed. How? We will explain this in today lecture. If there is a weak field ligand, weak ligands, if there is weak ligand, high spin complexes will be formed. High spin complexes will be formed. How? Today in this lecture we will explain all of these. So in this lecture, first of all, I'm telling you that what is strong ligand and what is weak ligand. It need the separate video, so I will make it as the separate video, that what is strong ligand and what is weak ligand. Here, if there is strong ligands, if there is strong ligands, if there is strong ligand used, if there is strong ligand used in octahedral complexes, what will happen? If there is strong ligand used, due to the strong ligand, the interaction between, due to the strong ligand, the interaction between, the interaction between ligands and central metal atom, central metal atom will be strong. Strong interaction will be present. If when the interaction between ligand and central metal atom stronger, the crystal field splitting will be, the crystal field splitting will be higher. If high crystal field splitting, if high crystal field splitting, if high crystal field splitting, low will be, low will be the electronic spin, low will be the electronic spin, electronic spin means it means that the central metal atom, the d system of the central metal atom, the electron will be, the electrons in dx. Dx means d of the system, where x is electron from 1 to 10, and d there is maximum 10 electron. The electron in dx will be followed, should be followed Horn's rule. Horn's rule. What is Horn rule? According to Horn rule state that the electrons will pair up only when each of 5d orbital is at least singly filled. When each of 5d orbital, there is 5d orbital in each sector. This is easy to history. According to Hund rule, first of all, each orbital will have singly filled. After that, the five each orbital filled. After that, the pairing will be occur. This is called Hund rule. So, according to Hund rule, the electron will be paired in this system, in the D system, will be according to Hund rule. When strong ligand will use the, when strong ligand will use the, so low spin will be formed, low spin complexity. So here you can say that here the spin is low. I will explain it after that, how the spin is low. So this is the strong ligand concept, and while when we use weak ligand, when we use weak ligands, what will happen? When we use weak ligands, the interaction between the interaction between ligand and ligand and central metal atom will be the interaction between central ligand and central metal atom will be weaker. When we use a central when we use weak ligand, the interaction between ligand and central metal atom will be weaker. So that's why the CFS crystal field splitting will be lower. When the difference between Eg and T2G, when the difference between Eg and T2G is lower in strong field complexes, it is like that. In weak field complexes, it is like that. Means the interaction, the CFS, the del naught is very low. The crystal field splitting is in weak field. In weak field, it is low, while in strong field, it is very high. It is very high. So that's why when a car in this case, first of all, electron will pair up singly, while in this case, first of all, here is three orbital. First of all, electron singly pair T to G set. After that, the electron will not go here, but it will go directly into. It will first pair the T to G set. So high spin will be obtained. High spin will be here. If the interaction between ligand and centimeter will be weaker, crystal field separation will be lower. Crystal field splitting will be lower. If crystal field splitting low, if low is the crystal field splitting, low will be high will be electronic spin. High will be sorry. Here is del not. Here is in weak field del not is greater, del not is less, while in strong field del not is more. So in this case, it first singly filled, while in this case in weak field it first paired the T to G. After that, the electron will go into the EG sector. So is it clear? So thank you. The crystal field splitting will, if the crystal field splitting high, high will be electronic spin. If electronic spin high, then it cannot be followed. If the crystal field splitting is lower, if crystal field splitting is less, so it cannot be followed home rule. It cannot be. It here here home rule Horn's rule doesn't obey it, because here is the splitting very little splitting. So the electron will first pair. After that, the electron will go into the EG sector. So in weak ligand, electron high spin will obtain, because first pairing will occur. When pairing will occur, spin will be high. So when the pairing is not occur, first when Horn rule followed occupied lie in strong ligand, so the low spin will be formed. These are low spin and high spin complexes. Concept of low spin and high spin in case of in case of octahedral complexes. Is that right? So now let's start. Let's move to the to explain weak field in one graph. So now I am going to clean this. You can also take screenshot from this topic, or also you can pause, you can rewind the video. Is it clear? So here high spin and low spin octahedral complexes. when dx means x is the number of electron in d system. When there is one electron in d system, when there is two electron in d system, when there is three electron in d system. While T2G, the electron in T2G set, while the electron in EG sets are how it is paired. Electron in T2G and EG, where Q means and P means, where P and Q is number of electrons in T2G and EG. P is number of electron in T2G and Q is number of electron in EG. While N is number of paired electrons, S is the resultant spin of the dx ion system. So let's see here. uh, T2G and P is electron in T2G and Q is electron in EG, where N is the spin of this system, and S is equal to S is the resultant spin of the well, N is the number of unpaired electron in the system, while S is equal to N is equal to number of unpaired electron, while S is equal to resultant spin of the system. So if if the system is strong ligand, if there is strong ligand attached, there is strong ligand system. If there is strong ligand system, what will happen? If there is in D0 D1 system, and D1 system, here there is in T2 set there is 3 orbital dxy dx dy. There here is 2 orbital, here is T2G, here is EG, here is N, here is S is equal to N divided by 2. So let's see here. When there is D1, according to strong, first I already told you that when strong ligand, the interaction between the splitting, the crystal field splitting will be higher. When crystal field splitting is higher, according to Hond rule, the electron will be paired. So first of all, electron will go here, and the remaining will be unpaired. The remaining will be empty. So here in T2G here is 1 electron, because here in T2G 1 electron, in EG here is 0 electron, where N is equal to number of unpaired electron. Here is only one unpaired electron. So S is equal to N divided by 2. N is 1 divided by 2. No, that means that S is equal to 1 divided by 2. S is equal to half. When D2 system, when D2 system, then in D2 system, one electron will be go here, one electron will be here. The EG will be EG will be 0, and T2G there is 2 electron. So the unpaired electron is a 2 electron. The resultant spin will be 2 divided by N divided by 2, means 2 divided by 2 is equal to 1. The resultant spin will become 1. When there is D3 system in a strong ligand, according to Hond rule, it will first paired. So in T2E, the EG will be empty, EG 0, T2G is equal to 3, unpaired electron is 3. So here 3 divided by 2, here 3 divided by 2. In D4 system, according to Hond rule, first electron goes singly unpaired. So electron will be go here in EG set. When they go into EG set, the T2G will have unpaired 4 electrons. The T2G have 3 electrons, while EG have 1 electron. So the total unpaired electron is 4. 4 divided by 2 is equal to 2. When system is D5, what will happen? The electron first go into first it will be go into T2G as well as EG. For all will singly filled, so T2G have 3 electron and EG have 2 electron. So totally unpaired electron is 5. So 5 divided by 2 is resultant spin. If 5 divided by 2 is resultant spin, when the system is D6 system, first electron will go here. So here first all is singly paired. After that the sixth one electron will be go ahead, that will be paired. So T2G has 4 electron while EG has a 2 electron. So there is a 4 unpaired electron, 4 unpaired electron. So the resultant spin will be 2. Similarly, when D7, it will be like that. Now I think you should be clear. That is 6 electron, 5 electron, Eg have 2 electron. There is 3 unpaired electron. 3 divided by 2 will be resultant spin. When D8 system, the first all is first of all will go singly paired. After that the 3 electron will be go here. So the 8 electronic, so that will be electronic solution. So the T2G has 6 electron, EG has 2 electron. The unpaired electron is 2 and the system, while 2 divided by 2 and the resultant spin will be 1. If there is a system D9 system, what will be happened? First all is singly paired. After that pairing will be started. So here is 9 electron. So T2G has 6 electron while EG has 3 electron. So here is only 1 electron and 1 unpaired electron. So 1 unpaired electron, no, that result spin will be 1 over 2. When the system is D10, when the system is D10, T2G has all his first singly paired according to Horn rule. After that the pairing will be started. The 10 electron will go here. The T2G has 6 electron and EG have 4 electron. There is no resultants, there is no unpaired electron, 0 unpaired electron, so the resultant spin will be 0. These are the electronic configuration, these are electron displacement, these are electron arrangement in the DX system. When there is strong ligand, the electron will be go according to this system like that. The resultant spin will be like that in each system, respectively in strong ligands. So you can also take screenshot from this topic. Is it clear? So now I am removing the system. You can also rewind the video. Okay, thank you. So here in system D, when there is a weak ligand or used, when there is weak ligand or used, so what will be happen? When there is weak ligand, the in D1 system, in weak ligand, first of all pairing will be occur because the crystal field splitting will be little lower. So when crystal field splitting lower, this energy with crystal field splitting lower, the electron will be paired easily. So here in T2G there is 3 sets, in EG there is 2 sets of orbital. So here one electron will be goes into T2G sets. It will in EG set, it will here is 0, in T2G here is 0 electron, here is 1 electron in T2G, sorry, in EG here is 0 electron, while the number of unpaired electron is 1. So resultant spin will be equal to 1 divided by 2. When result spin equal to 1 divided by 2, when the system is 2, so according to first Horn rule, follow Horn rule. uh, According to this, the T2G have 2 electron, 2 unpaired electron, and EG has 0 electron. So T2G has 2 electron and EG has 0 electron. So the 2 unpaired electron, 1 2 divided by 2 is equal to 1. The resultant spin will be 1. When the system D3 and D3 system, then the electron will be go into T2G unpairedly. The EG have 0 electron, so T2G have 3 electron and EG have 0 electron, while N is equal to number of unpaired electron is 3. So the resultant spin will be equal to 2, 3 divided by 2. When the system is 4, the first 3 cases in strong ligand and weak ligand are same, they are totally same, because here is no uh, uh, because all the T2G all orbital are degenerator. So electron first will be go first it will be paired unpaired. After that pairing will be started. So here in the D4 system, deposition first unpairing occur, the remaining one electron will not be go to Eg because the splitting is very less, so electron can be go to T2G. So here it will be go. So in T2G there is 4 electron, in Eg is equal to 0 electron. The resultant spin the resultant spin the remaining electron, the unpaired electron will be here 2. So the resultant spin will be 2. 2 divided by 2 is equal to 1. Similarly here is also like that. Here 2Tg5 Eg 0. Here is 1 electron, the resultant spin will be equal to 1 divided by 2. Here is also similar. You should be concentrate. 2Tg6 Eg0 1, not 1 0. So here the resultant spin will be 0. In D7 system, first electron will be uh, unpairing. First electron will be pairing, after that pairing will be started in T2G. The remaining one electron will be go into Eg. So here in T2G is equal to, and here T2G will be 6, Eg will be 1. So the here is 1 unpaired electron, so 1 divided by 2. In D8 system, first unpairing will be, after that pairing will occur, the remaining 2 electron will go like that. So T2G6 Eg has 2 electron, so there is 2 unpaired electrons, so 2 divided by 2 is equal to 1. So in D9 system, first of all pairing will occur in T2G. After that the remaining 3 electron will like that. First of all unpairing, after that pairing will occur. So T2G has 6 electron while Eg has 3 electron. So here is 1 unpaired electron. So the remaining the resultant spin will be 1 divided by 2. In D10 system, first of all pairing occur in T2G set. After that unpairing, after the pairing will be occur, therefore electron will go into Eg set. So here T2G is equal to 6 and Eg equal to 10. So result here is 0, so 1 divided by 2. So here resultant spin will be equal to 0. These all are about when weak ligands are used in octahedral system, then this happen. So now here you can see that when all complexes are respectively to strong ligand, here this is the system of weak ligand. You can also rewind the video, uh, repeat the video to when the strong ligand was used. So here is the weak ligand is used. When you watch that the resultant, when you compare the resultant spin of strong ligand and weak ligand, the strong ligand will have low spin, while the less spin, while the weak ligand will have higher spin. The resultant spin will be high as compared to the in weak ligand uh, as compared to the strong ligand. When the resultant spin of the strong ligand complex will be less, while the weak ligand complex will have high spin. So weak ligand will have a high spin complex, while strong ligand is called low spin complexes. These all are about the D system of the D system in octahedral complex. Are this is a topic of high spin or low spin in octahedral complex, or weak ligand and strong ligand complex. These are about, you can also screenshot, or you can take screenshot as well as you can rewind the video. So this is the today topic. Thank you very much. I hope you will be clear, your confusion will be cleared. So okay, thank you very much, goodbye, best of luck. Inshallah we will take another class about the tetrahedral complexes. We will apply the ligand field theory, crystal field theory to tetrahedral complexes. Okay, bye, best of luck, goodbye.